All right, welcome to another IAEI News Live. My name is Thomas Dimitrovich. This is a recorded session, and we're going to be covering a topic that you probably haven't seen covered in a long time. We're going to talk about cable tray, and it all starts now. All right, welcome back. Okay, so we're gonna use the 2020 National Electrical Code for our discussion today around cable tray. This week, as we speak, is NFPA 70E second draft meetings. So that's where I'm at today, out spectating and being a sponge and working on some change documents for you-know-who, the IAEI, and hopefully we'll have a document and possibly and a PowerPoint that you can use to understand the latest changes, the latest things that are happening around electrical safety. So let's, today's discussion is on, we're going to be working out of the book here. And if you think about cable tray, you should be thinking Article 392. So I want you to open your book to Article 392. Now I'm looking in the 2020 code, and before we stop today, before I end this session, remind me, I am going to go to the 2023 cycle, and we're going to take a look at Article 392 for cable trays, and we're going to see what's going on there. We're going to see if anything has changed. Now, you will see that Article 392 is separated into three parts. You've got Part 1, General, you have Part 2, Installation, and Part 3, Construction Specifications. Now, I'll tell you, I'm going to read to you Part 3, Construction Specifications, because there's only one section. But my book just exploded. I keep forgetting my book is in two parts, and the separation of parts. Anyway, I need a binder. That's what I gotta do. So Part 3, Construction Specifications, begins with Section 392.100. They have 5 sections, 5 first-level subdivisions. We want to state things correctly. They have strength and rigidity, smooth edges, corrosion protection, side rails, fittings, and non-metallic cable tray. So I would say, when you read the titles of those, you'd say, well, wait a second, most of that is manufacturer related. But in reality, it's application related as well. It does speak to like smooth edges. I mean, you're not going to walk around, for example, on the job site with a file and smooth off all the edges of your busway. I'm just saying that ain't gonna happen. That is a manufacturer. Quality, but you will be making holes and cutting holes possibly in your busway or cable tray. You might be, for example, like smooth edges, and what it says is cable trays shall not have sharp edges, burrs, or projections that could damage the insulation or jackets of the wire. So you've got to think about anything that you do, anything you modify in the field in regard to smooth edges. Strength and rigidity. Cable trays shall have suitable strength and rigidity to provide adequate support. Well, you'd say, well, Tom, I can't control how a manufacturer makes his busway. But you can purchase the right one for the installation. You can do your calculations for load correctly around bus or cable tray. I keep saying busway. So when you purchase your correct cable tray, make sure you get the right cable tray for the application. We're going to talk more about that. Corrosion protection. You're going to need to understand from for when you specify your cable tray, are you getting the right materials? Do you need stainless steel? Do you need, is there plastic? Do you need, what do they call that? Do you need a regular carbon steel or other types of materials can they put over the cable tray to help minimize the exposure to the environments, the impact of the exposure to the environments? So you got to think about where your cable tray is going and make sure you specify the right cable tray. Side rails. Cable tray shall have side rails or equivalent structural members. Well, what's really important about side rails is the height of the side rails and all that jazz. So make sure you get the right cable tray for the application. Fittings. Cable tray shall include fittings or other suitable means for changes in direction and elevation of runs. Okay, fittings. We're talking you might need expansion joints depending upon the application. You're going to need splices because you're going to put things together. You're going to need hangers, anything that's accessorized to get you from one level to another to secure it. All of that has to be the right parts for the right cable tray. Non-metallic. Whoa, we just said, I said plastic, but non-metallic cable tray. Non-metallic trays shall be made of flame retardant material. Well, there you go, flame retardant material. So now that's a manufacturer specification, but you need to make sure you tell the manufacturer what you're looking for. All right, so in part one is an important part. So they've got the scope of the scope of the article. So this is basically giving us this is going to tell us, I mean, the scope is a very important part of the article. This is what's going to help us understand what is covered and what is not covered, right? So what 392 covers, ladder trays. So here you go, ladder trays. What am I looking for? I'm looking for a button. I'm looking for a button. Right, so ladder tray. They cover ladder tray. Ventilated trough, ventilated channel, solid bottom. Solid bottom. Now let's take a look at the differences there. So ladder tray, look, they have it looks like a ladder, but don't use it as a ladder. Come on. All right, so solid bottom trough cable. This is a solid bottom with built like a trough, right? So that's another one that is used. And there's your ladder tray, ventilated channel. So there's your ventilated channel tray. Solid bottom and other similar structures. So they cover a little bit of everything for you in that scope. So you got you have ladder tray, ventilated trough, ventilated channel, solid bottom, and other similar structures. Now they do have one term, one definition, and I can tell you that the definitions in 2023 code cycle are all moving to Article 100. So that's a given. So this definition for cable tray system, which is an assembly of units or sections, and all of the fittings forming a structural system used to securely fasten or support cables and raceway. So they define a cable tray system. Now I wonder where in here they use that term, or did they just get it? They do. Cable tray installation. They got a complete system in section 392.18. Cable trays shall be installed as a complete system. And it says cable tray systems shall be permitted to have mechanically discontinuous segments between cable tray runs or between cable tray runs and equipment. So they do address and they use the term. So great job to that code thinking panel. All right, so let's talk. All right, now, if you look at part two of, These are all the different sections that are a part of part 2. They got uses permitted, uses not permitted, cable tray installation, cable and conductor installation, number of conductors or cables. That's going to be important. Why is that going to be important? A lot of different reasons. You got heat, you got weight, the whole bit. Expansion splice plates. Why is that important? You don't want it pulling apart in the field. Bushed conduit and tubing. So you've got to make sure, you've got to be careful on how you get conductors into the cable. So you got to think about a couple things. You have to think about how you're going to mount your cable tray. You got to think about what's going to go in the cable tray, right? The conductors. You have to think about how you're going to get those conductors into the cable tray. You don't want to void the UL listing. You don't want to compromise the integrity of the tray itself by cutting holes in the wrong locations. Follow manufacturer's instructions. Always follow manufacturer's instructions. Flip come off. I don't have my right one. Oh well. All right, so always follow manufacturer's instructions. And then you got to think about how you're going to support. So that's a part of the installation, right? So you're going to think about how you're going to support your cable tray as well. All right. And not all cable tray is not all cable tray is considered the same. Now you've got to think a little bit about the materials. Let's go there. Let's talk about the materials. Let's talk about how important it is to get the right materials on the job. Now, I'm just trying to find the right, there we go. So here are your different types of cable tray. You've got steel and suitable environments for steel. Indoor, pre-galvanized, that's the word I was looking for. Hot dip galvanized, non-saline hot dipped galvanized for indoor, outdoor. There are some advantages. Low thermal expansion and contraction. So that's a nice, if you think about what could happen in some of these installations, right? What you don't want to happen, let me find it here. I know I've got a good picture of this. You don't want heat to cause, yeah, here we go. How about this one? Expansion and contraction has to be accounted for. Vertical runs, long horizontal runs. You don't want that to become an issue for you. And I do have thermal expansion. I swore I had a good picture of thermal expansion. Yeah, you know, you might. Yeah, there we go. This might help. So you can see a little bit down on this image. You want to consider the expansion and contraction from an environmental perspective. And be aware, be mindful that your outdoor installations are going to present a lot of unique considerations. I mean, you'll have, especially where you're at environmentally. If I'm near the ocean, I'll have environmental considerations. If I'm in Arizona, as opposed to Weirton, West by God, Virginia, that's going to be a different environmental consideration that I need to think about. So all of these different materials are important to understand the capabilities of your cable tray. All right. Okay, so the ladder. So in a ladder type in ladder type cable tray. Now, regardless of the materials, in a ladder type cable tray, I would argue that ladder type is probably the most widely used cable tray in industrial and commercial applications. I would say you'd be very hard pressed. It would have to be a pretty unique home, residentially wise, to have cable tray in it. I'm never going to say you will never see cable tray in a residential home. Ain't gonna go there. Ladder type tray, I would say, is the most widely. The rungs give the anchor points for tying down your cables. Very nice for that. And then what's really cool about the rungs in a ladder tray is you can bring the cables in and out of the cable tray through those rungs. You can come through the bottom of the tray or the top of the tray. Very convenient. You don't have to cut any of the material away to get your cables in there. Now, you're not going to be coming through the sides. If you have a ladder tray that does not have covers, you can have very good airflow for cooling of those conductors through ladder tray. These are all reasons why you'll commonly see ladder tray being used. Dust buildup, very minimal because the dust can go down through. Now, dust can stay on top of the cables, and obviously it's how full you have the cable tray. But the ladder tray offers the opportunity for the dust to fall down through. Moisture can accumulate. That's another very good aspect of ladder tray, because the moisture can go down through it. So very good. Hazardous or explosive gases can't be piped from one area to another, like you might have with other types of wire methods for moving cables around the facility. Remember, you're going to move cables around the facility. You're either going to put it in conduit, you're going to put it in cable tray. You're going to have to do something to get a conductor from, say, a switchboard to a switchboard to a panel board. You could have medium voltage, low voltage. You're going to be using cable tray for something, and it's going to be moving, getting a conductor from point A to point B, or a group of conductors from point A to point B. The widths of cable tray, you can typically, you'll get these in 6, 9, 12, 18, 24, 30, 36 inches, up to 48 inches. And then the rung spacing, you can get different rung spacing. Why would that be important? How many conductors you're bringing up in and out. 6, I think up to 8, actually up to 18 inches span in between rungs, and as close as 6 inches. Now, the wider the rung space and the wider the cable tray width itself, just think about what you're doing structurally. You're reducing the structural capabilities of the cable tray itself. So you got to remember that. And make sure whenever you're looking at the cable from a cable tray manufacturer, that load reduction may not be in their published tray loading charts. So read those charts very carefully. All right. If it's a small conductor, you're probably using 6, 9, or 12-inch rung spaces, I would say. Trying to think of anything else. Type TC, if you're looking at small diameter cables like your TC cable, PLTC, ITC, can't think of anything else there. But in any case, you're going to go to and think about the wire that's going to go in that cable tray to help you determine your spacings. And be mindful too that on some of the cables, if you put too large of a span, I mean, this stuff is, I'm going to say common sense. I'm never going to use that word either. What I think is common sense might not be common sense to someone else. You're going to you got to think about the distance between those rungs, the distance between the side rails, the width, right? If your rungs are too far apart, you can get cable drooping. You don't want droopage. You don't want your cables like doing this inside that inside your cable tray. So you be mindful of the I'm trying to think of the rigidity of the cable itself, especially small conductors. Small conductors, you're going to have to think about you got to think about the small conductors and the proper distance between rungs. I'll just leave it at that. Now on your solid bottom, and again, you got material, and then these are all structural considerations for the cable tray itself. From a solid bottom perspective, if you have a large number of small diameter conductors, that's where you'll typically see a solid bottom trough cable tray. They usually come with covers, like wraparound covers, and then because in some cases you might have to worry about the EMI, your radio frequencies and things like that, especially if it's data cables. The smaller conductor is typically going to be your data cables. So there are methods to build that, like, I don't know, quote unquote Faraday cage or whatever you want to call it around that, just for EMI or RFI considerations. You're shielding, basically. Just try to think. So obviously, in the previous ladder tray, cable tray, we had, without the solid bottom, moisture and everything can go through. With a solid bottom tray, you've got to consider the fact that you could have water settling in there if there any kind of depending upon the location. So think about location. Think about where you're going to have this, and you might need some weep holes drilled. Follow manufacturer's recommendations, instructions. In many cases, they'll have you drill a weep hole like every 3 feet to limit that water accumulation. Water is not good. I mean, your cables might be rated for moisture and all that other good stuff, but you've got to think about the integrity of the cable tray itself. The channel tray. So let's think about channel tray. I would say channel tray is used when you're doing cable drops from, say, one level to another, like a main cable tray to the equipment or device being serviced or served with those cables. So you'll see that these will help you in that transition. For smaller instrumentation cables, so these are typically 3, 4, and 6 inch widths, I would say, somewhere in that ballpark. Trying to think of what else. Channel tray is for smaller instrumentation cables, all that good stuff. Effective for alternative to large conduits for supporting cable drops from the main cable tray. I already said that. Trying to think of things that you might help you understand the application of that. In all of these holes that you see where you might have cable coming out, they'll have bushings that should be installed in there because you don't want any edges to damage your conductors. So be very mindful anytime you take a conductor through a cable tray opening, like holes like this. Look for those grommets that can be placed in there. What else? What else about? Okay, so let's talk about supports, because now when you start to in the general application of your cable tray, you have to think about where you're going to, like if you have split, obviously you can't get an 800-foot run of cable tray. It's going to come in sections, and then you have to put it together. So your standard NEMA lengths for cable tray, this is going to be in feet, not inches. You got about 12 foot, 20 foot, 30 foot. I think there's one in between 20 and 30. I think 24 feet. I'm mistaken. So you got, say, 12, 20. I should write these down myself so I can. 12, 20, 24, and 30. Those are the lengths from the NEMA perspective. Now, a manufacturer can offer different lengths. So you might find a manufacturer that, say, does 40 foot or some other distance. But the NEMA standard lengths, which I should reference, there are two documents that are referenced in Article 392. There's an NEMA VE, and for further information on cable tray, see NEMA VE, Metal Cable Tray System. There's also a NEMA 105, Standard for Installing Metal Cable Tray Systems. So, now, you've got to think about how much weight is going to be on the cable tray, obviously. For example, so what we're showing here is when you have when you're doing splices, the proper method for splicing and the proper way to connect two cable trays together is very important. So a splice plate, that plate that you see in between there, that's what's going to bring two cable tray together. The support span, okay, that's the distance of the cable tray between the supports. So now the length must always be longer than or equal to the support span that you have selected for your installation. So where those supports are, obviously you don't want to make it equal. You want to make it longer, or you could do it equal, then you'll be right on the supports as you see there. I personally like a little bit of overhang, and I like to keep the splice in between the supports on either side of the splice. Only one cable tray splice plate be placed between support spans, matching the tray length, etc. Right? So those are just you got to think about your supports. You got to think about the weight that is going to be placed on your cable tray. So 8 foot, 12. There's your 8, 12, or 16. I think I said. Can't remember what I said. I said the NEMA, if I'm not mistaken, were 12, 20, 24, and 30. So you had 8 foot, 12 foot, 16 foot, and 20 foot. Okay. So in any case, so there's your span. That's these are the different spans in between the bracings, right? So, and this is what this is how I always like to install busways. I want to keep those supports before the end of my busway. Your load weights, these are the different, these are the NEMA load weights, A, B, and C, 50 pounds per foot, 75 pounds per foot, and 100 pounds per foot. And you'll typically see that on the tail end of the numbering of the busway. For example, and I know I have so for example, NEMA load class is a combination of a number and a letter. So 20C, there C is your 100 pounds per foot. So a 20C tray is a tray strong enough to support 100 pounds per foot of cable of weight when the tray is supported every 20 feet. So, and then that's your span, right? So that's your span over there. That's your 20-foot spans. That's your every 20 feet of support. And you'll notice where the splice plate is on this one here. It's right here in the center. So I'm going to use my laser. There's your splice plate on this one that's between these spans. You never want to have more than one splice plate in between spans. So there are a lot of little details. Now, let's take a look at what the code says. Cable translation complete system covers in portions or runs where additional protection is required. Covers or enclosures provided the required protection shall be of a material that is compatible with the cable tray. They have your troughs, your partitions and walls. Discussion: cable tray shall be permitted to extend transversely through partitions and walls, or vertically through platforms and floors. So there's your marking. I'm just looking to see cable and conductor installations. Cables over 1,000 volts and then operating 1,000 volts or less. Number of multi-conductors, ladders. Okay, ladder or ventilated trough trays containing any mixture of cables. So this is getting to your different types. Just trying to see if there's somewhere in here that speaks to. Here's your expansion splice plates. Expansion splice plates. Now, what do we mean by expansion? Well, what we mean by expansion is, in some applications, depending upon the application, you might have an installation where the material itself expands and contracts. So what you don't want to do is create a situation where you have a problem with your cable tray installation because of temperature changes. So I was just trying. I thought I had an image, but apparently I don't. So understanding where and how often to allow for thermal expansion and contraction is a very important part for the longevity of the cable tray. Now, what the code says is just that expansion splice plates for cable trays shall be provided where necessary to compensate for thermal expansion. So you've got to determine when is the necessary. Now, there is a in VE2 2018 standard for cable tray installation guidelines addresses. This is a NEMA VE2, and this is I believe there's a 2000. I don't know. I can't remember what the latest version. I think it's 2018, but I'm not sure. Cable tray expansion. This document helps you understand the cable tray expansion and gives you guidance on determining the gap settings between tray sections, as well as the number of expansion plates required in a tray system. So when the code says expansion splice plates for cable tray shall be provided where necessary, the where necessary, you can base it upon your years of experience, or you can base it off of a document. NEMA VE2 is a good resource for you. And I would say that expansion and contraction and the failure to account for that is the number one issue leading to premature failure of your cable tray systems. So keep that in mind, that the environmental conditions that you place your cable tray into plays a very important role in the longevity of the cable tray. I keep wanting to say busway. I don't know why. Geez, because you know what? We hardly ever talk about cable tray. Yet it's a very important topic. All right, so accurate from a gap setting perspective, at the time of installation, I don't know that the code talks about gaps. Cable trays shall be supported in intervals in accordance with the installation instructions. You have allowable fill area, flange connections, cable splices, not splicing your cable tray. No, they don't talk about it, but it's if you at the time of, but remember, you have 110 that tells us follow manufacturer's instructions. Now, so when there's an expansion gap in between two pieces of cable tray that you have to consider on, and it is set based on the total temperature differential with respect to the temperature at the time of installation. So there's 4 steps that they'll typically follow. I don't think I have a slide on this. Step 1, you'll take they'll give you a chart, and you establish the highest expected cable tray temperature during that year. So you have to understand the temperature of the environment that you're putting this cable tray into. Then you think about the lowest expected cable tray temperature during the year. Then you use a chart. You basically draw like a line between these 2 data points, and it will accurately give you a gap setting for your cable tray expansion. So they'll go through, take the maximum temperature, the minimum temperature, you draw a line in between these 2, and then you'll determine your gaps based on that. So they give you the NEMA VE2 will give you the method for determining the gap for the installation of expansion splice plates. So that's a very important piece of the puzzle. Also an important piece of the puzzle on the material, whether you use aluminum or steel or like a fiberglass type of cable tray. Those will all differ, obviously, in their expansion and contraction because they're different materials with temperature limitations. What else? Then you'll have a maximum spacing between the expansion joints and all that jazz. So those are just some things to think about. And that expansion plates was 392.44 in the National Electrical Code. Expansion splice plates. It looks like that was added in the 2020 code as well. So they did some changes. And in 392.30, they talk about securing and supporting. Cable trays shall be supported in intervals in accordance with installation instructions. See, you got to follow manufacturer's instructions and guidelines. And go fall back on the NEMA guidelines too, but think about the manufacturer-specific cable tray, because they might have specific requirements for their cable tray. They know how it's constructed. So you can use the NEMA guidelines, which is a good document, because all the manufacturers are contributing to that, making sure that it suits their installation there. But you might have you might be able to do something a little better or custom pertaining to a specific manufacturer. They talk about the cables, securing your cables and conductors inside. Cable ties shall be listed and cable ties. I remember when this went in. This, I think, went in the 2020 code. Cable ties shall be listed and identified for the application and for securement and support. Those little ties on bread are not good to use at work for your cables. Just saying. All right? All right, so let's now importance of picking the right cable tray. So here's an image of cable tray that has wind damage. I mean that's not a good one. Here, so that's wind damage, right? So that's wind damage. This next one, if I'm not mistaken, this next one is corrosion, right? Picking the right materials is plays an important role in the application of your cable tray. So this is chemical corrosion and atmospheric corrosion. And this, I believe, is in a paper mill. That's not only not good for the cable tray, it's not good for your conductors either. So you've got to make sure you pick the right materials. So you think about chemical corrosion. When does chemical corrosion take place? It's when metal comes in direct contact with some corrosive material, solutions, whatever. So the concentration level of the chemicals, it could be in air, could be in liquid, mists. The duration, it could be an all-day type of thing. It could be, 7 days a week, 24 hours a day, 365 a year, or it could be very short durations periodically. And then the temperature plays a role as well. So for any degradation, those are sort of some of the things you need to think about. It's worse outdoors typically. I don't want to say always, but typically outdoors is going to be worse than indoors. But again, on indoors, you got to think about what's the environment, what's in and around. Is it like a swimming pool area, right? And we've all been through those discussions with regard to having materials in those areas, like around swimming pools. You got a very caustic area, and that I would say is probably more that everybody can relate to, because not all of us work in hazardous location or in not hazard, but in chemical plants and things like that, where you might have caustic environments on a wider scale. But you got to think about the location, whether it's salt in the air, dirt in the air, sulfuric acid in the air, if it's airborne, if it's a liquid, if it's a gas, whatever your cable tray is exposed to, you don't want this to happen, right? You don't want that to happen. You don't want the wind to twist it. You don't want ice to form and add weight, right? All of that type of activity can overall damage your cable tray. So environmental conditions considerations are very important. If you know you're going to have ice weight, then you might have to plan for it, right? So ice loads, typically, I mean, this is a pretty harsh installation. What you would typically see is like a glaze on top of your cable tray, okay? And in it's hard to stop that. Outside of putting your cable tray indoor, which would probably defeat the purpose of why you're using it and where you're using it. But what you can do is include that in your weight calculation. So there are ice load, there's methods to do that, snow load as well. So you got, here in West by God, Virginia, we have ice, but we have also snow. You can't stop the snow from flowing, but you do have to plan for it. So snow loads, they measure those by density and thickness, and it can be considered. Density. We've all experienced the light. Well, some of us have experienced light, fluffy snow and heavy, wet snow. You've got to talk to your weather service. You have to look at the environment conditions in the areas where you're going to be installing this, especially if it's outside. Look at your snowfall rates, all that good stuff. You got to think about wind. I mean, that was this. You got to think about the wind load. Most of your outdoor cable tray systems are going to experience wind, and you have to design for that. There's not going to be anything in the National Electrical Code. I mean, they'll tell you to install per manufacturer's instructions, but they're not going to tell you how to calculate wind load, right? They'll tell you to make sure it's braced, make sure it has access, make sure that that it's marked, all that jazz. But you're not going to sit there and say, hey, make sure it's rated for the wind. You have to make sure that it's installed per manufacturer's instructions, and you have to consider all of these applications. Well, we do address splice plates. We address the tubing. securing and supporting both your cables and your cable trays shall be supported at intervals in accordance with the installation instructions. They talk about the number of cables, conductors that can be placed in there, the ampacity, flange individual conductors or multi-conductor cables with entirely non-metallic sheets shall be permitted to be enter closures through openings. They tell you how to make those openings. They talk about cable splicing, but they're not going to give you wind loads in here. They'll say strength and rigidity. Cable tray shall have suitable strength and rigidity to provide adequate support for all contained wiring. Well, how do you count for wind? You need to determine the wind loads. And most of the outdoor applications are ladder tray. And the most severe wind loading will be the impact of pressure to the cable tray side rails. So the general impact pressures corresponding to various wind velocities will be available from tables from the manufacturers, and you can take a look at the wind velocities in the area where you're going to be making the installation, and look at the pressures that are impacted and design for it. So you've got to make sure that you design for wind. You've got to make sure you design for ice and corrosion, all of those things. And when is that important? How do you address some of this stuff? You got to pick the right materials, right? You've got to pick the right materials, whether you pick steel, aluminum, stainless steel, fiberglass, and understand the advantages of each. Understand the maximum continuous recommended temperatures. Fiberglass is 90 to 120 degrees Fahrenheit. Aluminum, 180 to 200 degrees Fahrenheit. Low carbon steel, 400 to 500 degrees Fahrenheit. Stainless steel, 800 degrees Fahrenheit. If you are designing your system, you're going to be your cable tray system, because that is a defined term. Let's go back. Cable tray system, a unit or assembly of units or sections and associated fittings forming a structural system used to securely fasten or support cables and raceways. We do this we have to consider all of these things, take all of this into consideration. It's a very important part of the installation, is to ensure the integrity of the conductors that are going to be inside this cable tray. Precious cargo. You damage the conductors, you can cause arcing faults, arc flash events. The equipment won't operate as designed. I mean, 70E goes out the door. 70B maintenance. Let's take a look. It's a good question. I'm glad you brought up 70B. Let's take a look at I'm going to look at the latest version of 70B, which I don't have a printed copy yet. But if you go to nfpa.org/70B, next edition, sign in with your email address, and it's free. They just want to make sure they know who's out there. Let's take a look. Chapter 19 is cable tray. What does it say for cable tray from a maintenance perspective? This chapter identifies electrical maintenance requirements for cable tray systems, including ladder, ventilated trough, ventilated channel, solid bottom, and other similar structures. Chapter 9 has the frequency, visual inspections. So you're going to verify grounding and bonding. Oh, very important. And make sure that your equipment is listed for grounding and bonding. Right? So 392.60. 392.60. Grounding and bonding, metal cable trays. Metal cable trays these are permitted to be used as an equipment grounding conductor, where continuous maintenance, 70B, and supervision ensure that qualified persons service the installed cable tray system, and the cable tray complies with this section. Metal cable trays shall be grounded as part for the conductor enclosures. In 250.96, Part 4 of Article 250. Metal cable trays containing only non-powered conductors shall be electrically continuous through approved connections and bonding jumpers. They got transition guidance here. Steel or aluminum cable tray system shall be permitted to be used as equipment grounding conductors provided all of the following are met. Okay, so there's 4 items that need to be met. 1, the cable tray sections and fittings are identified as an equipment grounding conductor. These are the sections and fittings. The minimum cross-sectional area of cable trays conform to the requirements in 392.60. And that in there, they talk about the maximum fuse size. They talk about the cross-sectional area of the metal from a steel tray or aluminum tray. All cable tray sections and fittings are legibly and durably marked to show the cross-sectional area of metal in channel cable trays or cable trays of one-piece construction and total cross-sectional area, both rails for ladders. So there's legibly and durably marked to show the cross-sectional. Cable tray sections, and that's for inspection purposes and maintenance purposes. Cable tray sections, fittings, and connection raceways are bonded in accordance with 250.96 using bolted mechanical connectors or bonding jumpers sized and installed in accordance with 250.102. So, what are we talking about there, Tom? Well, let's, where's it at? Could have swore I had a good picture of that. I know I do. I know I do. I know I do. Go and find it. There we go. Now, there, see that jumper that's across that splice plate is, or expansion joint, is a method to ensure the bonding. You'll look at this in the installation, and you'll find a lot of different areas of bonding. Proper bonding. Here's another one. Here's a good one here. Okay, support potential for cable tray guide to interfere with splice hardware. So using the wrong fittings, that's just an example. All right. I like that. I like that picture there because it really helps you understand, shows you the bonding between the two. So 70B, visual inspections. You're looking for verify the bonding, cable tray, transition raceways, check for overfill, inspect corrosion, incorrect cables, cable damage, inspect the following spacing of cables, cable tie downs, support of the cable tray, damage tray or supports and expansion joints in sufficient distances. They talk about cleaning, keeping the debris off the top of it. You don't want buildup of contaminants, negatively affect the performance. They reduce the life expectancy. They want you to do infrared thermography. You got to make sure that there's not current flowing through that raceway and creating heat. Test cable tray effective ground fault current path. So those are all the things that are going on in 70B. 70B does address the cable tray aspect, or does address proper maintenance of cable tray. Okay, so here are your two documents. You have ANSI NEMA VE 2017 for cable tray systems, and your NECA NEI, I guess it's an NEIS standard, but NEMA 105. It's a general how-to. Remember that the manufacturer standards are by manufacturers for manufacturers. How to test for loading, etc., and labeling all your materials. Tests are conducted in a specific way. Simple span, no splices, span tray lengths, tray ends not clamped down, and then a loading to failure, and that gives us the weight capability. Third-party observers typically not present for those. 36-inch wide is tested in a long length, and they give you those. There's sort of how they do it. You'll see how they put the bars in there, and they again load it to failure. There, we already talked about the 20C and your NEMA load classes. Already talked about that. There's your VE2 again. Support installation, location of supports, field modifications, all that good stuff. Horizontal supports should not be greater than the straight section length or as recommended by the manufacturer. More than one splice, no more than one splice is located between supports. I believe we already covered that. Vertical supports, you want to support at center, guides at top and bottom. Support at the center. Fitting supports. So these are all of your, these systems can get pretty cool. Within 2 feet of all openings, support under the fittings, and they'll give you, this is great information. You can pull these from manufacturers. Manufacturers will give you the information that you need to install their cable tray. 2 foot of adjustable splices, supports within 2 foot of expansion splices, right? So we see some of this on photovoltaic installations too, on the racks and whatnot. They'll tell you how far from the splices and expansion joints that you need to support. So it's this is all structural. It's all structural engineering. Within 2 foot on each side of the expansion plate. So this one here is a bad example. This one does not have a support within 2 foot on each side of that expansion plate. It's only on the one side. Safety, sizing, control. Article 392 gives us all the safety and the sizing for the control signal data and the power cables. 6 to 36 inches, your standard. Your ladder is 6, 9, 12, 18 rung spaces. Solid bottom vented trough. Side rail heights 4 to 8 inches. Lengths 10 to 40 foot. Fittings, bend radius 12, 24, 36, or 48 inch bending radiuses. Article 392 determines the cable tray width. And that's all based on the type of cables. Side rail height, it depends on the load and how much cable you can put inside of it. And remember too, on wind resistance as well for outside. Side rail is gonna play a role there. Cable load, width ends up being governed by the code and is determined by the number of factors: cable type, cable voltage, cable diameter, tray bottom type, and cable fill. Communication cables, 50% fill ratio. This is how you do your calculation. You take your tray area, say a 12-inch by 3-inch is 36 square inches. You do 50% fill. So what do? You take that 36 divided by 2 or multiply it by 0.5, and that's 18 square inches. Then you do your cable areas and make sure you don't exceed that 18 square inches. And you can do your number of cables. Those are your data. Power cables, multi-conductor, 4/0 and larger. You'll do similar calculations. You'll look at the cross-section of the cables and the cable tray, how they lay in that cable tray. In some cases, you want all of those to be just one layer. You don't want to stack them on top of each other. Every application is going to be a little bit different. Power cable, single conductor, 392/80 A to D, with not less than 2.15 times the conductor diameter between groups. So you've got to, in some cases, this is where you'll need your ties, and you want to maintain that distance between those conductors because it's a code requirement, and it's all about air circulation. It's all about your ampacity calculations, your conditions of installation. Permits the tray to be classified and used as an equipment grounding conductor. We already talked about this. There is no such thing as UL listed cable tray. That's an interesting fact. Metal area requirements. So this is do not use as a walkway, ladder, or support for personnel. So it may look like a ladder. They may call it a ladder tray, but do not use it as a ladder and don't walk on top of them. That would be ungood. They'll give you the information you need to calculate your cross-sectional areas and use for the use. Let's take a look at this real quick. Whoop, dadgummit. I want to look at nope, I'm not going to look at it. All right. 392.60a and 250.96 cable tray systems that support electrical conductors to be electrically continuous and effectively bonded and grounded. Requirement applies whether or not the cable tray is used as an equipment grounding conductor. Bonding jumpers, you have to have your bonding jumpers in place. We saw some pictures of that. And this is two troughs coming into a lower trough that might be going the same direction or a different direction, and you're spilling into that and then moving in. They have to be bonded together, even though they're separated. Or because they're separated. 392.18 for raceways terminating at the tray, a listed cable tray clamp or adapter shall be used to securely fasten the raceway to the cable tray system. Make sure you use the right products for the application. Table 344 to obtain the support requirements for other conduit sizes. So now, and we said this before, solid, unventilated covers and how they're installed. So they have to be identified for use with that cable tray. Not over 95% of the allowable capacities of. So again, where cable trays are continuously covered for more than 6 foot with solid, unventilated covers, not over 95% of the allowable capacities of table 310.15. So here's the thing. Remember, conditions of installation. When you put covers over top of the cable trays, you're causing the retention of heat. And that's ungood. So you have to account for that. Where? In the ampacity calculations of your conductors. All right, look at this. Missing supports. This is what can happen because of the weights. If you don't have the proper supports, you can get sagging of the cable tray. And I'll tell you, you see this, that is ungood. Ungood. So electrical inspector rejected the installation for incorrect support locations. This is where they had the support locations. And you can remember what it says. No more than 2 splices or expansion joints between supports. And look at this one. There's 20 foot. There's the 20 foot. So there's 2 splices in between the expansion joints. That's where the sagging occurred. Right in there. There are 2 expansion joints in there, or 2 splices. Incorrect. So, okay, cable tray shall be supported at intervals in accordance with the installation instructions. So you're going to follow manufacturer's instructions or industry guidelines. Those that NECA document or NEMA document. The support span should not be greater than the straight section length or as recommended by the manufacturer to ensure no more than 1 splice is located between supports. It's not rocket science. It's not that hard. You just have to pay attention to the details. That's all. It'll serve you well for many years. Not requiring a radius vertical adjustable splice plates can be used. Supports should be located within 2 foot of each side of vertical adjustable splice plates. Look, there's another missing splice plate. This would have been the proper way to do that installation. The green and the yellows, that is where you should have added, they should have added additional supports. Here's another little case study. Look at this puppy. That doesn't look good. It can't be good, right? Look at this, huh? Expansion and contraction misaccount for vertical runs, long horizontal runs. And we saw one of these before, support at the splice plate, right? So what you want to do is you need NEMA VE2 section 341 requires supports within 2 foot of both sides of an expansion splice plate. And that's not what they did. They have the bonding, they have the splice plate, and they have the supports. Support at the splice may create problems. Simple beam causing maximum deflection due to maximum positive moment at the support location. Typical span configuration, maximum positive moment, maximum negative moment, and they'll give you a little design and show you where you might want to place or not place your supports. Potential for cable tray guide to interfere with your splice hardware. These are your supports. There's your splice plates, minimum deflection within 2 foot of expansion plates. So remember to always follow manufacturer's instructions, and supporting is important. Conduit penetrations. Let's take a look at the other side of this installation. This is a problem, right? So there's a lot of things going on here. You've got to follow manufacturer's instructions whenever you're penetrating into the sidewalls of a cable tray. I mean, you might hurt the integrity of the cable tray, the structural rigidity of the cable tray. They'll tell you how to put those, how to put the materials in, how to enter into the cable tray the right way. So your conduit has to be sized correctly and secured correctly. And you probably want to come in over the top and dump into the cable tray, right? So follow manufacturer's instructions. Anytime you start cutting holes in equipment, I don't care if it's busway, if it's cable tray, if it's panel boards, switchboards, anything you start cutting holes into, you better have manufacturer's instructions to support the activity that you're doing. Here's another. This is a creative support method that was employed at a facility that was not per manufacturer's instructions. Those are problems. Use the listed equipment. Follow manufacturer's instructions. Use equipment that are identified for the purpose for that installation by the manufacturer. They'll tell you how to support the installation. All right. Bus or cable tray. I keep wanting to say busway. Cable tray. 3, remember to always follow manufacturer's instructions. We know we looked at 70B. We said cable tray in Article 392. We know that it is a part of the next edition and the previous edition, but it's in Chapter 19 of 70B for the next edition that will be published next year. We talked a little bit about the maintenance for proper maintenance of cable tray. We talked about the materials of cable tray. We talked about structurally supporting cable tray. What else did we talk about? I think we had a lot of information about cable tray. Wind loading, ice loading, the environmental conditions, modifications to how to get cables in and out. Cable tray could impact the ampacity calculations, especially if it's covered. The NEC is going to tell us how wide and how tall those sides need to be based upon the number of conductors. The NEC is going to tell us how many conductors can be in there. Cable tray can be a very valuable asset to getting conductors from one point to another, but you've got to make sure you install them correctly. Get them inspected. Look for your supports. Get those 2 NEMA documents. They'll help you. Understand the proper installation. Follow manufacturer's instructions for installing cable tray. Cross your T's, dot your I's, everything will be well. All right. I believe that concludes another IAEI News Live. I really appreciate you spending time with me today. And I appreciate what you do for the electrical industry. Remember, this week, right as you are watching this, NFPA 70E is well underway, second draft meeting. They will be buttoning up that document, and more changes are coming to that document as well. I'll tell you. Oh, I wanted to look at 392 for the next edition. 70 next. We're going to look at 392 for the 2023 code cycle. I said I would do that. Let's take a look at the second draft, and you got to look at the first draft. I'm going to open them both. All right, so first draft, chapter 3, 392. Cable trays. They moved the definitions to the front, so we knew that was coming. In 392.10, uses permitted single insulated cables and single insulated conductors. So they talk about uses permitted and not permitted. Single conductor cables and single insulated conductors. So they added some new terminology with regard to single insulated conductors. This is first draft. What else did they do? They did some style manual changes. Style manual changes. Style manual. In 392.56, cable splices and type MV cable joints. Cable splices and type MV cable joints, so that was added, and type MV cable joints. So, and the justification for what is an MV cable joint? Type MV cable joints was added to correlate with Article 311. All right, and we're going to see if that stood that's all. All right, so not very big changes in first draft. Let's take a look at second draft for 392. Not 392. Yeah, 392, not 382. I looked at 382. All right, so 392, what does 392 say? This is second draft. All right. Style manual changed. They took type EMT and type ENT. They removed the word type, and just electrical metallic tubing is EMT. Electrical non-metallic tubing is ENT. So they took the word type out of most, except they left it in UF, type UF, ungrounded feeder and branch circuit cable. So they removed type from some of these, like LFNC, LFMC, IMC. They left type in for ITC, instrumentation cable tray. And let's take a look at why they removed the word type. It's been removed from the new definitions found in Article 100 for conduit and tubing. The reference to type has been removed for the article in the purview of CMP 8. Type has been removed from the new definitions found in Article 100. So they removed the word type from those definitions. So they removed it here in Table 392.10a wiring methods. And that was it. Not a lot of changes in 392, not a lot of significant changes, but changes nonetheless. All right, that's it. I'm done. Thanks, and I think we're going to close up shop. Thanks for joining for another IAEI News Live. Thanks for what you do for electrical safety and for the electrical industry. Remember to stay safe and please stay healthy. See you next week, Tuesday, same time, same channel.